Right. So can I welcome everyone to the meeting, welcome everyone here in the hall with us here at the United Augustine Church on George IV Bridge in Edinburgh. Welcome to our ASE members who are joining us on Zoom, and also welcome to other members of the public who are joining us on YouTube. Our main speaker tonight is going to be our friend and colleague Will Joy, who is going to speak to us about finding space rocks. And we're also going to have a Sky in December presentation from our equal friend and colleague Nigel Goodman. I also have apologies tonight from the Vice President of the Society, Andrew Farrow. Andrew couldn't be here in person. He's joining us online tonight. Andrew had hoped to bring our stunning ASE lapel pin for those of us here in the hall. Unfortunately, they are not available tonight, but we hope that they will be available if you return in January to our next meeting. As I said, welcome to everyone. We have one new member to welcome since the last meeting, and that's Andrew Chalice. So can I invite everyone here? And oh, Andrew is with us. Hello, Andrew, welcome. Can I invite everyone here and everyone online to welcome him? And so with that, with Andrew's membership, that takes us up to 155 members of the Society, which is a fantastic number. And we're very happy with that, and we hope the Society will continue to grow. As you'll see on screen, we're good value for money. An annual membership is £30 per annum. Our concession is £15 per annum. And if you're wondering what the concessions are, if you log onto our website, those details are on there. Now comes the greedy bit. Just to remind members that renewal of fees was due on the 1st of October this year. If you have not renewed your fees yet and you wish to do so, you can find out how to do it online on the website or contact our treasurer, Alan Ellis, who will help you with that. If you joined after April of this year, then you don't have to put your hand in your pocket again until 2022. So just a brief word about one or two things that are coming up. Firstly, the Society is planning to hold another telescope workshop. We undertook the first of these in February of last year, right before coronavirus hit. So we haven't had an opportunity to run another one, but we're planning, again, coronavirus allowing, to run another telescope help shop in 2022. More details of that will come forward in the January newsletter and at the January meeting. The intention of these help shops is really to help people who've recently had purchase of a telescope, or maybe don't feel as confident in using a telescope, particularly if you get one for Christmas, on how to use a scope and operation of a scope, and then obviously interesting things to look at in the night sky. So if you are interested in taking part in such a workshop, obviously places are limited. Even pre-COVID, places are limited, and depending on demand, we will try and schedule more workshops as time goes by. However, if you can let us know via email, those details are on the website. You'll also find some interesting information on the website about objects to look at in the night sky. Speaking of staying in touch, on screen now should be the various details of how to get in contact with us. You can obviously contact us through our website, which is astronomyedinburgh.org. We're on Facebook at Astronomy Edinburgh, or on Twitter at AS Edinburgh, or indeed, if you're watching us on YouTube, then you have access to our YouTube channel, but the details are on screen there. Just a brief word about some of the events and meetings we have coming up in the next couple of months. So our next event is the monthly meeting of our Imaging Observing Group. That's obviously for ASE members only, and that's online, and that's this coming Wednesday, the 8th of December. On the Friday, the 17th of December, we'll have a talk from Martin Lund on Thomas Cook, telescope maker to the Empire. So that should be quite interesting. I believe that's purely an online presentation. Our next hybrid monthly meeting here at the AUC Hall in Edinburgh will be on Friday, the 7th of January, when Rebecca Higgett is going to be speaking to us about Neville Maskelyne and the global projects of 18th century astronomy. So we're a society that looks both backwards and forwards, which is quite nice. On the 21st of January, we're planning to hear from Dr. Elizabeth Stanway on building galaxies one star at a time. Again, that should be wholly online on both Zoom and YouTube. And for our February monthly meeting, hybrid meeting here in the hall, on Friday the 4th of February, we'll be hoping to hear from Giles Hammond about upgrading the 20-inch Grubb Parson telescope at Glasgow University. And finally, for the moment, you'll see there on screen that on the 18th of February, we're hoping to hear from Lynn Smith of the British Astronomical Association on a presentation titled Red Sun. So without further ado, I am going to hand over to our friend and colleague, Will Joy, who's going to speak to us about his, I guess you could say your passion. Is that the correct word? Your passion for finding space rocks. I don't think we'll have to go into space to find any yet, but we may find out otherwise soon. So be a short interruption while we change presentations. Right, apologies for that small hiatus. Hopefully both everyone in the hall and everyone watching online is now seeing the presentation. So I will hand over to our colleague, Will.
Apologies about that, but at least we're rocking and rolling now. So I arrived here in Edinburgh at the end of the 90s, actually, and my interest in meteorites started at that time. I was away working quite a lot of times in desert areas and such like, and I met a guy called Dr. David Gavin, late Dave Gavin, who's up at the Astronomy Society, and Jamie Shepherd as well, who used to be a member of the society. And there was a guy, a mutual friend called Stuart Forbes. Stuart Forbes, Jamie, and Dave both inspired me to look for meteorites in the desert. And that's how it started. And then I went out, and then things just took off. So I owe a lot of thanks to Jamie and Stuart for that, and of course, late Dr. Dave Gavin. So for no further ado, we shall plod on. So what is a meteorite? So basically it starts as a meteoroid. This is a particle or a big body which is outside orbiting the planet or in the solar system, and it's a fragment of rock which is just around there. And when these fragments of rock enter into the solar system, if they're small enough and they completely burn up, they're classed as a meteor. And if they actually come all the way down, then land on Earth, they're a class as a meteorite. And these meteorites can be absolutely microscopic. They can be micrometeorites, sort of known as interplanetary dust, or they can be up to many centimeters, tens of centimeters, and even more, as we know. They enter in through the atmosphere and burn up and can cause amazing fireballs, and some of you may have seen some great fireballs and fragmentation due to pressure waves and all this kind of stuff. And they're just fascinating things, fascinating to see, but when they land, that's what I'm interested in finding them. So there are three main groups of meteorites. The stony meteorites, composed mainly of silica minerals comprising chondrite and achondrite meteorites. Chondrules are small, glassy, spherical beads, and basically achondrites and chondrites make up the most primitive asteroids, and made up from chondrules and metallic grains, which have been preserved from origin of the solar system 4.6 billion years ago. Chondrite meteorites are made from fragments of these asteroids, and stony achondrite meteorites are typically fragments of asteroid crust where melting has metamorphosized, removing their chondral structures. Iron meteorites, composed of iron metal alloyed with nickel. These are from the core of a magmatic or differentiated asteroid. And these asteroids are internally melted and separated into a metallic core, silicate mantle, and a crust. And the area between this is the sort of differentiated meteorites, the stony iron meteorites composed from a mixture of iron, nickel metal, and silicate minerals. These so-called palisade meteorites are from the core mantle boundary of the differentiated asteroid. So now this is really what my talk is about, and this is my passion, is looking for meteorites. And so identifying meteorites is quite something. And what we actually got here, I've got going to be running a quiz, so it'd be great if you could actually really keep a good eye on this. I've got 10 rocks, 2 of which are meteorites. And so learning about what just going through what I'm saying here will help you to identify the 2 of the 8 meteorites. And I'm going to be actually offering a meteorite to a lucky person who actually finds the 2 meteorites. This will be talked out later on. So basically, we're going straight into identifying a meteorite. So their blocky nature, as we can see, is one thing. They have many thumb-like imprints and hollows, and they have a kind of, they exhibit, they have a fusion crust, and as they come through the atmosphere, a fusion crust forms, and it's about 1 millimeter, forms about 1 millimeter thick. And so you tend to find that these rocks are very dark in color, although you can have some very rare meteorites which have a very light colored fusion crust. They also exhibit, you can see a lot of shock lines on a lot of these rocks, and they contain a lot of native iron, so they can be attracted to a magnet. Some of the rarer meteorites, the achondrite group and planetary meteorites, don't actually contain much or any iron, so they're harder to find, but they do not attract a magnet. The rocks are generally much heavier than normal terrestrial rocks, and they are geologically different. The majority of meteorites are found from the chondrite group, and you can just about see in the center of this picture here, you can see one of meteorites which I've got, which shows a chondritic structure. This, if you were to use a sort of break them or use a diamond file, you can open up and you see these chondrites, and there might well be metallic grains as well, and it's good. This meteorite here is an example of the interior of a carbonaceous chondrite meteor, and this photo is courtesy of one of our ASC members, Angus Self. This is a very primitive carbonaceous chondrite, very famous, and it's similar in nature to the recent meteorite which we had in lockdown, which fell down in Gloucestershire. So it's quite rare, so it's nice to see that one out. The next thing in identifying meteorites is their shape. This is meteorite M65. You can actually see it down on the table here after this. And if you look at it, you can see there's a bladed lip. And underneath, if you were to turn it up, you'd see very small lines of flow. To give an example of this, I'll just flip to the next slide. This is the SR-71 Blackbird, which is the fastest plane ever. And this is the meteorite M65. And it's no coincidence that it's a very similar shape. If you actually look at this meteorite head-on like this, you will actually see the lip of ablation and that's similar to the design of the SR-71 Blackbird. And basically these meteorites and tektites were used to design very fast vehicles, re-entry capsules coming back into the Earth's atmosphere. This is another example of large ablated flow lines seen on Meteorite L008, which is again down here. And we can see big chunky ablated bits of rock which have come off. And this is really, as the meteorite has just, again, like M65, has just glided through the atmosphere. It hasn't tumbled, hasn't turned, has just come down. The next thing which you see, and this is shows quite clear the fusion crust, which you can see, which is about 1 millimeter thick. But this part of a meteorite actually exhibits secondary fusion crust. And what's happened here is, as the meteorite has come through the atmosphere, its pressures have been so extreme that pieces of the meteorites sort of broken up, fragmented. Once the main crust is formed, there's been a fragmentation, and it's still going fast enough with huge amounts of air resistance that the inner part of that meteorite begins to burn up. So you can see here that it's almost like a glassy finish. It didn't get to the stage of the full blackened fusion crust, but it's getting there. And again, there's an example which you can see down on the table. The definitive lab test for meteorites is effectively the presence of nickel. Nickel and iron are only really merged together in extraterrestrial form, and so it's very unlikely that you're going to get a rock which has native iron and nickel, and lots of the chondritic meteorites as well have a lot of nickel in there as well. So it's also, strangely enough, I've noticed on some meteorites which I found, even some very old ancient meteorites which I picked up, they smell. They react with air, vapor, and water, and they have lots of minerals inside which break down due to moisture, and you get a kind of a pungent sulfur smell which comes out of these meteorites. So that can be another telltale sale. And but the main thing is, with a meteorite, if you think you've actually found one, look around. Are there lots of other rocks the same around? If you sort of found a nice, lovely black magnetic rock, which you very, very common here in Scotland, are there many more similar ones? And if there are, then you probably find it's just a native geology which is there. Here we have some examples of typical meteorons, and majority of these are actually man-made slag, which are shown here. This is actually from Dunrobin Museum, Dunrobin Castle Museum up in the Highlands. But you've got slag, you've got old rusty iron, and you've also got lots of pieces of unexploded ordnance, which do over time look and seem to be like meteorites. You also find, especially here in the UK, you get lots of sedimentary ironstone nodules, which again look like meteorites, but they do not, they're not attracted by a magnet. And then of course we've got all the terrestrial volcanic and igneous rocks which do mimic meteorites. And so here in Scotland is a very, very difficult place to find meteorites. So places to look for are ideal places: dry desert areas, ancient non-igneous geology. You want an area which is clear, free of vegetation, and has had minimal human and animal habitation. A good light-colored background rock is obviously very, very advantageous for looking, and so that's what's when I was working a lot in deserts, and with my interest in astronomy, this is what led me to looking for meteorites there. Here we have a couple of a very bad and an ugly location, and this will come very apparent quite soon. So we've got if you were to look at it, the bad one is actually the one with the trees. The ugly one is on the right side, which is in the desert area. You can actually see there's an oil rig there. This is in the very I would call bad and ugly extreme. We've got, I was looking, and that's actually a meteorite which I found there. But if you look closely in the photograph to the right, you can see there's a tiny little sign, and from the next side you see what that is. Basically, there are minefields there, so that was a really awkward place to be looking for meteorites. Absolutely terrible. This is actually the remains of an F-4 Phantom plane, which was returning from the Iran-Iraq war and crashed. Where this was on the Iran-Iraq border, where I just happened to be wanting to look for meteorites. And then when I realized how many mines there were around, I very quickly stopped going and looking for meteorites. My biggest concern is actually next to my watch there is a little mine, and you see that little piece of black. That's the piece of black metal which would blow your foot off, and that's the size of the mine. And anti-personnel mine. It's actually from Italy, that mine. And but these things are just around there. And once or twice every 10 years when it rains, even though these mines have been cleared, waters comes down and they just get washed around all along these desert floors. So it's very, 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 very difficult and very dangerous. Other hazards. This is I was actually in Australia gold prospecting, but looking for meteorites, and I was with an ex-girlfriend partner, and she went off ahead, and after we've been assured you would never see a snake out there in Australia. I was actually trying to buy snake traps before, and she just raced ahead and walked straight over what she thought was a stick. I carefully stopped her, pointed at the back, and that's a king brown or copperhead snake. Would have killed her if it had been. So all these things are out there in the desert. So I'll take you on a little bit of my journey. Now, I know that some of you have seen some of this before, so I've done my best to get a few additional photos and different videos, actually. So some different ones. So we've got this is the kind of place which I like looking. It's even though statistically you think you're going to find much better meteorites on a very flat, open surface, it's often in these rugged, rocky places with undulations and stuff where people haven't gone, where there's a chance of finding a lot more meteorites. So this is kind of places which I like. So this is me out searching in the desert a number of years ago. I'm looking quite a bit younger there. I tend to basically go out there with my desert gear, have a little rucksack, which I've just taken off because it had the tripod on when I took these photos. I carry a kind of 5-liter bottle of water at the start of the morning, and I have my geological hammer, my GPS, a little waterproof notebook. And you have, even in the desert, you think, why do you need a waterproof notebook? It's just for the sweat. You have so much sweat that you want to have these things so your own sweat doesn't just take all these things off. And I just basically just drive out and look for meteorites, but spend a lot of time walking. You see on the second photograph, I actually have I take a satellite phone with me, and actually have a watch that is a watch. It's actually got an EPIRB in it if worse comes to worse. So that was quite full belts and braces there. First tip is kind of look after your vehicle, in my opinion. This is the photo to the left. It was just before I went down into this sort of salt plain with the vehicle, and I'm looking happy. I think, oh yeah, I'll take a photo, you know, show people what I've been up to. Drove down into this salt flat and got very, very worried. If you drive along these salt flats, you can actually get to a point where you could just fall through. All four wheels could go down, and there's just no way out of that. So I realized that, and then made my way out, but had to try and get out very quick because I was worried about getting stuck. As I came back up over the bank, I got a puncture in my front tire, and you can actually see this is after I changed the wheel, but in doing that, the first two bolts which I undid, they broke. Bolt one broke, bolt two broke. I then had a bit of a Panama moment. Had my early evening meal, which is the sun's going down there, and just put some oil from my tin of tuna fish on there, and then managed to get the wheel changed. Then this is more punches. This was actually the next day. So I carry 2 or 3 spare wheels with me in the car now when I go around. This is looking in the desert. This is actually a lot of dirty detritus there. This is to the left are black rocks. They're actually just bits of limestone which are covered in a kind of a black fungal growth, which is on there, sort of desert varnish, but it turns them black. And to the right is actually that's the remains of a plastic bottle. I'm going to play a video now. It's not a video of looking for a meteorite like it was last time. So see if I can do that.
In the afternoon.
I shall just have to. I have to just get this. See how I can do this. So I'm flipping it across there. So I have to actually have to stop this when I. Sorry about this. Well, we shall move on. We shall skip that video. It was basically just looking around, giving you an idea of the terrain which I was going through. Here we go back quite a few years. This was my first success out in the desert. And this is after 11 days of searching. And I basically was out there driving all the way around an area of the Middle Eastern Peninsula, just looking for meteorites, and just didn't have any success at all. And then ended up just pulling off the road, getting some sleep, waking up in the morning. And then this was day 11, and just saw a little bird fly, just followed this little bird, and then ending up finding a tiny little meteorite, which was about the size of my little baby finger. This led on to a stream field. And I'll give you an idea of, see if I can get this video working now. see if I can get this. Actually, oh, it is going on now.
I'm out here.
There we go.
Looking for rocks. Well, I'll just pan over, show you the old car.
Have we got a volume on the
Walking along, it's what it's like. Some black stuff everywhere. Walking, walking, walking. Scrubland, there's bush, and then you walk along. Footsteps, I've actually just walked a little bit up. I've just come back.
basically, I'm just walking up to this this meteorite here, this black rock.
There's a noticeable object here.
And this is the I hadn't got any further than that.
It's like finding rocks. There we have it. Close up. View of scale. My hand. Watch. Actually quite a fair size. Okay, so this is number 2 of the trip. B002 on the 20th of February 2007. Over.
There we go. And this is the kind of photo which I take. I take a photo above, and then I take a horizon view as well. You can see that's my hand wrist GPS and a couple of compasses for location and a rule. After this trip, I got one of those little scale cubes and made it a lot more professional. Actually got 2 compasses there. The reason being is the trip before, I actually had one compass unbelievably just completely flip on me. I just could not believe it. I thought I was going crazy. And so 2 compasses go with me all the time now. This is a more recent one, D001. And this, you can see, is one of the meteorites which go on the table here. And this is a lovely, lovely, lovely specimen. It was actually harder than you think. I'm quite close here when I'm photographing it, but the color of the rock means that when you actually, if you look at the geological background, when you're actually quite far away, more than sort of 20 meters away, that rock would just blend into the general rocks. So it was kind of a chance find as I was walking along, and you can actually see just behind it, just above it, you can see an ancient tire track. And this kind of desert areas, these tire tracks, a tire track will stay in a desert area for about 60 years. So it shows how little changes in these desert areas. And it's the reason why I don't just drive everywhere. I try and drive to one location, take a walk for about 1 kilometer away from the vehicle, walk around, and then drive on. If I was to kind of be driving up and down like a sort of a lawnmower, I'll just be destroying the desert, and it's not right to do that in such a beautiful place. This is a nice oriented meteorite, L006, and again, this can be shown. Is shown down here, and this was quite an interesting find. As I was, this one I actually found as I was driving, and I came across it, and I thought, right, I've actually found a load of meteorites, because I could see a few more black things in the distance. And as I walked over, I found there was just black piles of tin clans, which was completely rusted as I walked on. But this one is actually a beautiful one. You see it there, and that's me here. You can see that's with the normal GPS, which I've got there, and the wrist one as well, photo. So now this L008 is the big oriented one, which you saw in the early photographs with the bigger bladed flow lines on it. And this was actually found, it's actually a sort of shallow hill, and it's like an iceberg as you see there as it's underneath, but it was quite a surprise when I dug it out. And if I just go up, I'll show you this video I don't think anybody's seen before. So just do this one now. flip it across.
L008, a lovely oriented dendritic meteorite found here on the 9th of February. Good few kilograms there, probably about 4-5 kilograms. Look at the beautiful location, but just to show you the orientation here, you can see lines of flow would have come down like this. And a bladed rock would have just come off as it streamed out there. Beautiful specimen, like an iceberg, just a tiny little bit sticking up above the rocky sand here. And this was hidden underneath. Anyway, we'll be joined on 9th of Feb, here in the desert. Bye for now.
I was actually so surprised with finding that normally when I pick up the meteorites, I have my white gloves on, so I don't actually contaminate them. But that one, I just, as you saw, just got carried away, as this rest of the video shows that. So this is the time where we can have a think about a little quiz, which we can do afterwards, and we can do after Nigel gives the Sky presentation. Basically, what I've got a table here with 10 rocks on it, and 8 meteorons, and 2 of them are meteorites. And I've also got photos for the slides for you guys online, which I'll go through now. And what I propose is we'll have a look. You can, if you want, you can ask any questions, but I will just mention a few little things about them, and then feel free to, either if you're a member and you're here, you can just put your name down on the piece of paper with the numbers that you think are the meteorites, or if you're online, I'll give you my email address at the end, and you can send that in. And what we do is we can get all the names of everybody who gets it right, and maybe the next meeting we can draw them out of a hat, and the person who gets drawn, I will make sure that meteorite gets to them. And just so you know, I've never actually bought or sold a meteorite in my life. This is just a passion for me, looking for them. So we go on for these meteorons or meteorite. So this is mainly for the online guys. So this is the sample one. This rock is actually, it attracts a magnet, and it's relatively heavy. You can see, as my gloved hands, so you can see the size. Again, for anybody who wants, you can have a look at this afterwards. This is sample 2. This is actually been cut. But if you look at it, it's quite heavy, maybe not as heavy as the last one, but it's got a kind of, appears to have a kind of crust to it. Now this is sample 3. Now this is a very, very heavy rock, and it's magnetic, and it's, if you look at it, it's got interesting, I would just say interesting features, but then you kind of have to look at what these features could be. This is a smaller one, sample 4. And this one here, again, is relatively heavy, but it's quite smooth. And there's, I don't know whether you can quite see it. You can see it in person. There is actually a slightly lighter area to one of the areas of it. And there's some very small lines on it. Sample 5 has begun to degrade quite a lot since I picked it up, and it's still in its box. It's kind of heavy. It's a little bit of magnetic feel to it, but not much at all. And there is actually a bit of smell with it, but this is this, it could well be something else. Sample 6, it's kind of, it's a heavy piece again. It's got mixtures of minerals in there, and it's not really magnetic. Sample 7, this is not as heavy as some of the other ones, but it exhibits some classic forms that you might expect from meteorites, which have got a small sort of central amount where everything else is eroded away. Sample 8, if you actually look at this, it's quite heavy, and it appears to have lots of little sort of striky lines down, very, very small sort of lines, but it's up to you to make your opinion if there are anything. It's not magnetic at all, this one. And sample 9 is very dark, as you can see, but it's actually probably per size and volume, it's the lightest rock out of the lot. And then we have sample 10 is this one here, and this is quite heavy, and it exhibits, I think, just a fraction, a little bit of magnetic in one part. So out of those, people here can enjoy over a cup of tea, have a little think what the two meteorites are. And I won't bother playing this video, but this gives you kind of another view of one of the meteorites which I've got here, which we've got, which is L022, and it is quite a bit of a fun story with this. The previous meteorite, L021, I was actually revisiting the first area where I'd ever found meteorites, and I put in my handout GPS a coordinate where I thought I could find a meteorite, and I just took me about 3 hours to traverse this 17-18 kilometers, stopping every couple of kilometers to look, take a little stroll, see if I saw anything. Didn't find anything, and then just as I got to where my GPS says approaching direct destination, there was a black rock, and it was just amazing. It makes me think: is the meteorite actually trying to find me, or am I trying to find it? You know, I really did think that with this one, and this was a one which I found after there, where I'd been walking about 1 kilometer away from the car and found another one. That's a close one here. So moving on, this is back in 2017. We actually had a British Astronomical Association exhibition, and here in Edinburgh, and this was in Chambers Street Museum. There's a couple of older members here, Dr. Dave Gavin and Ron Liversteve, sadly passed away, and Jamie. But those two guys in the middle, their legacy is they have asteroids named after them. So I thought they were quite topical to have here in the talk, as they're orbiting around there, and maybe one day may come back to Earth as meteorites. And this is again a little display which we had there for the day, which is quite good. This is Gus, Angus self, and myself, and there as well. And then that's it. So really, I've got a little bit more which we could show, but I'll wrap it up here for now to give us a little bit extra time so that you guys can have a look and try and work out which two of these rocks are meteorites and have a look at some of these other things. So thank you very much. Apologies about the technical difficulties, and also apologies, I've been quite worn out from studies, so maybe didn't flow as good as it could have, but it's been it's a pleasure to be here. Thank you.
was fantastic. Thank you, Will. And so I think we'll now open up for questions, both questions here in the hall and also online. I'll come to the hall first. If anyone wants to indicate if they, we have one. Right, we've got lots of questions in the hall. So what I'm going to do is we're going to have roving mic go around. If you can just wait until you've got the roving mic, otherwise colleagues online won't be able to hear your question, and it just saves us having to repeat for the benefit of people online. So question number one, if you'd like, if you're comfortable, and say your name and just ask your question.
Hi, my name is Jamie. Where would you be most likely to find an asteroid, or
to actually find a meteorite? I mean,
sorry.
Statistically, they are all over the place, and it's just about balancing that game of statistics. It's about going to a sort of clear geological area, and as already mentioned, sort of something which is quite stable. Countries which aren't wet, which have a lot less vegetation, are obviously prime examples of that, and that's where you've got Antarctica and their desert regions are the best places to look. But then, if you keep looking at the sky, there's an active fireball network which is out there, and we've got in fact Jamie, who I mentioned, is one of the guys. He's got his own little 360 camera, and people are actually looking whenever there's clear sky, as you do in Scotland, which isn't that much of the time. If there are any fireballs, they're trying to record them, and then it's actually been sort of seen, as we saw with the meteorite in Winchborough down in Gloucestershire last year. They actually saw the fireballs and then worked out where it's going to be, and then people, obviously it helped that a meteorite actually fell on someone's driveway. But all these things come together. But really, there's a chance you could be looking at anyway. I mean, those rocks which I've got there, the meteor rocks, to give you an example, they've been picked up by me from deserts to Leaf Walk. So anywhere, even on my roof is where one of them has come from. So they may not be meteorites, but they could be meteorites. And unless you look, you don't know. Thank you.
So I think we'll take 2 or 3 more questions from here in the hall, and then we'll see if there's any interest online. So it's at the microphone's discretion. I should say, while we're waiting for the next speaker to come online and ask a question, we will endeavour to put Will's images on the website later on, so people can once again have an opportunity to guess which is a meteorite and which is not. So question 2.
Yeah, I'm Gillian Pickup. Hi, interesting talk. I was just wondering how you number them. I see you have some kind of system with a letter and
absolutely. What it was, every trip I decided to have a different letter. So the first trip I thought meteorite, I'll just do M. So but then I kind of went A, B, C, D, and it just went there. And then 001, that goes in the GPS, and a number of them will be meteor rungs as well, but they all get recorded and then looked at. So, but thank you, Gillian.
We'll try one more from the floor first, and then we'll see if we have some interest online.
Hi, Will, it's Andrew. A few years since I heard you speak on this, and my memory may be failing, but when you get to the point in the desert where you take your water and your rucksack and stuff, you've got 360 choices as to which way you go. It isn't obvious, so how do you decide?
Well, what I tend to do is, to be honest, I just drive out into the desert, park up, walk half a kilometre, and just walk in a big circle. And if I find something, great. If not, I just drive on another 5-10 kilometres and then look, and just keep doing that, and until I find something. And occasionally I'm lucky. I actually maybe drive past one, but that's very rare. It's normally in that walking that you tend to find one. So
we'll come back to the hall in a minute, but I just want to see if any of the members on Zoom have any questions.
Yeah, so we have a question from Tosh, if you want to ask. Tosh? You're on mute.
Can you hear me now? Yes. Hi, well, thanks for that. That was fascinating. I'm amazed with your dedication to go to such barren places with 5 litres of water. But in terms of meteor, I'm just interested why the meteors tend to be sitting right on the surface. There's no visible crater, which I would kind of expect there to be when one landed. And if they'd landed low, I would have expected the wind to sort of cover them in sand, that sort of thing. So why are they just sitting there ready for you to pick up?
These are a kind of historical falls. So they may well have been lying around for sometimes up to 10,000 years or more, or maybe just a few hundred years, or maybe even a few days. But basically, the meteorite comes down, and when they're this kind of size, they end up impacting the ground at their own terminal velocity. So they're not coming in at absolutely superb speed and then, you know, sort of embedding themselves 2 meters into the ground. They're kind of coming, landing, not really making much of a crater. But these, which I'm finding, are rocks which have been there for probably, in some cases, thousands of years. So they've kind of just got themselves to onto bedrock and onto the top. But actually, the important thing about desert and sand is that you tend to find larger rocks do work themselves up. Small grains of rock do drop in between. So over time, when you get windstorms and stuff like that, you do actually tend to find that the larger rocks actually lie towards the surface sometimes, unless the sand is really, really soft.
Okay, thanks.
And we also have one from Andrew. If you want to ask, Andrew.
Thanks. Hi, well, that was a great talk. I thought you persevered well at the beginning. That was absolutely wonderful. The shot lines that you mentioned on one of the early slides, I couldn't determine if it was sort of waves that it created, or was it the white lines in the rock or in the meteorite?
Oh, well, sorry, what was that, Andrew? Were you talking about the?
There was an early slide showing a meteorite with white lines on, sort of striated, and I wondered if when you said it was evidence of shock waves, whether it was wrinkling or were those white lines part of the shock?
Yeah, what they were, they're lines of weakness in the meteorite, probably as they've come through the atmosphere and they've begun to crack. But also, these lines of weakness allow weathering in, and those lines probably had bits of calcite and sand that had formed inside them. So that's why they'd come up as white. But it's quite a classic thing when you see a number of meteorites with these lines of shock in them. And they can be 2 things. They can be due to the actual shock, but also they can be due after with effects of weathering, which have opened up these cracks a little bit more.
Thanks, Will. And I'll take your advice. I won't look in Scotland.
That's right.
That's excellent advice.
Hello, Sarah. Hello, Sean. There are some questions that come directly to me.
Okay, Peter.
There's one from Ian Smith. Do you want to come on, Ian, and ask your question?
Yes, thanks, Will. I'm just wondering, in any of future expeditions, if the use of a quadcopter would help doing radio searches away from where you're standing.
Looking with a drone would be a very, very good idea, actually. Is that what you mean by a quadcopter, Ian?
Yes, to help you cover a larger area.
I think it would. I mean, the only thing is you'd have to get quite close, because as I found, I didn't play it this time on a previous talk, which was a more extended talk. It's amazing the detritus out there and how a tin can and even a piece of vegetation looks like a meteorite until you get quite close. But if you've got a good solar charger for your quad drone or whatever, then you could have it running all the time, and that would be, you could sit in a deck chair, I suppose, and just zoom this thing around and look. That would be a good idea. Thank you.
There's one from Derek Henderson. Are you there, Derek? Or do you want me to ask the question? I can ask it for you. Is Antarctica a good repository? And if so, why?
Antarctica is a very good repository because it's incredibly dry. It's the driest place on the planet, and that's the main reason. Plus, it's untouched by really untouched by humans. So there hasn't been development there and mass disturbing of the lands yet, and hopefully it remains that way.
Right, I think we had a few more questions here in the hall. Do you want to put your hand up if you've any more questions? We've got one at the back and one at the front. So why don't we start at the back and then work our way forwards?
Go on, yeah. Hi, Will, it's Hugh here. That was fascinating, and I now understand your passion for it. My basic question is, have you been able to connect any of the individual meteorites from one to another in a nearby location, or are they completely random and just pot luck?
Absolutely. In fact, the first meteorite I found was actually, I've got it down here. I can bring it. Normally, I would actually just throw this to you guys and you'd hand it around, but we can't do that with COVID at the moment. So, but it's actually a very small piece that size. That led me to finding a strewn field, and of which M65 is one of the later finds from that, which is that beautiful oriented one. And I've mapped all those out with GPS, and you actually see a strewn field pattern, which is formed there. But most of my meteorites have come from different areas, so away from that original strewn field.
Thanks. Before we check in with YouTube, we have a question from Nigel.
That was a fascinating talk, Will. Thanks very much. I wondered with on the assumption that there's many people like you around the world out there and wandering about in the desert hunting for meteorites. You must be gathering a lot of scientifically useful information. Is there any sort of organization on a worldwide basis or a national basis that coordinates the kind of information that you guys are gathering?
Absolutely, there are. I got my first ones classified, which I found at the Natural History Museum. And if you actually look at my meteorites, you see that they haven't been cleaned or anything. I've still kept them in their way. So I hope to do further research on them. But there are meteoritical. There's the meteoritical society, which I'm a member of. I've got a journal over there, but there's also there is the main thing of the meteoritic. Yeah, there are. So it's but it is necessary to get all of these meteorites looked at and classified, and that can be quite difficult actually. So to do so, especially if you get a few of them. So it is good.
Hi, Sean. Sorry,
yes,
this is Sarah again. We've just got a couple of more questions. Sorry if that's possible on Zoom. So we've got one from.
Go ahead.
We've got one from John, if John wants to ask, and then one from Bruce.
Evening. Thanks very much, Will, for your talk. It's very interesting. I think actually you've just answered it. I was asking how you actually get them classified to confirm the meteorites from the meteorons. As you said, some of them you got done by the Natural History Museum down here in England. Is that
yeah, the first ones I did, and then after that you can actually you get a feeling you know what a meteorite is. I was actually hoping to be involved and try and learn how to properly classify and do research into them myself. But that was a chapter of my life which didn't quite happen, and so I'm still hoping for that one day. Which is why, when you take a look at these meteorites, they're still kept. I haven't even cleaned them. You know, they're still kept, and they're kept in a low humidity atmosphere. So that's what I'm hoping.
Thanks very much. By the way, I'm supposed to have quite a few in my back garden, buried in the chalk. but they need an electron microscope to see them after you've dissolved the chalk, apparently.
Hopefully your back garden is both snake and landmine free.
Absolutely.
Do we want the last question from Zoom there, Sarah?
Yeah, Bruce, if you want to ask.
Yeah, thank you very much. Is the distribution of all these meteorites around the world homogeneous? Is it uniform?
It's pretty much uniform. It's just the nature of being able to be in a place where you can find them, and being able to be in a place where they don't degrade and just disappear into dust. They're falling pretty much randomly everywhere on the Earth. It may seem that there's sort of pockets of them where there are. I mean, it could be seen that the way the Earth moves through around the sun and through our solar system, that it can inspire, statistics could mean that the meteorites may fall in different areas. But I think, to be honest, it's pretty random and equally distributed. And if you think how many meteorites will be falling in the sea, that's another place where they go and are never found again.
Thanks for that. And would it be a good place to look in the centre of Australia? There's a lot full of desert out there.
Absolutely, yeah. I mean, I've looked in Australia. I haven't had success, but mind you, I was looking for gold. Didn't have success with that either. I've actually worked down a gold mine in Northern Territory, and many years ago, saw gold and copper then, but I haven't had any success from meteorites there. But it would be something. It would be an interesting place, but places. I'm now thinking of Spain might be an option. You've got semi-desert areas in Spain, for example, and a few meteorites have been found there. So,
thanks for the talk, by the way, Will.
Cheers.
Right, I think that's probably all the time we have for questions. Before we move along the agenda, can you all show your appreciation for Will's talk tonight? Thank you.
All right, so we're looking at what the sky in December holds for us. And I'm asking the question, is this the best time of year? Well, we have astronomically dark skies more or less for 12 hours at a time, from roughly 6 o'clock to 6 o'clock, which gives us lots of time to observe and to image and to just simply enjoy the dark skies as much as we can, depending on where our location is. And also, perhaps it's not too cold. Famously, when I first started astronomy, I would be sitting out in the back garden on an upturned bucket beside my telescope, absolutely freezing to death. So perhaps December is just that nice balance between dark skies and being not so cold. But this will just be a taster, as most people who enjoy the night sky, to whatever level they want to enjoy it. A bit of planning always helps your enjoyment of the night sky. So this will just give you a sort of a rough idea of what to expect. And if you're going out there to look at particular things or whatever, there's plenty of references out there, both online and in print, that you can go to find out where things are going to be and what times they're going to be there and how to look at them and so on. So first of all, we'll start with the constellations. This is looking south, and these times are good for the dates and times that are shown there. And I would like to thank Alan Pickup for helping me on that data. Looking south, the circumpolar constellations, the ones that revolve around the pole star, which looks as if it's just sitting steady in the night sky, it doesn't move anywhere. These circumpolar constellations, Cassiopeia, Cepheus, Ursa's Major and Minor, Draco, Camelopardalis, are always with us. They're high in the sky. And of course, the Milky Way itself just arches across our heads at this time of year. So if you're in a really dark part of the world, then you can often get some quite spectacular views of the Milky Way itself. And at this time, the late summer and autumn constellations like Cygnus and Pegasus are now giving way to other constellations of the winter, Perseus, Auriga, Taurus, Orion, and Gemini. And in the latter part of the night, other constellations associated with winter are starting to rise. So Leo, the lion, Virgo, Coma Berenice, and Bootes and Hercules begin to rise as the nights go on. The first week of the month and the last week of the month are going to be the darkest with the moon out of the way. So round about now, basically, once you all get home and have a look outside, if it's clear, you should get some nice dark skies with either no moon or a crescent moon. I think it's a new moon tomorrow, actually. So looking north, these are the constellations that are available to us. Ursa Major at these times standing on its handle. As the year progresses, Ursa Major revolves like all these other constellations round the pole star, and at these times in the winter, it's often not in its classic layout, if you like, horizontal, but standing on end. And you have also Ursa Minor, Cepheus, Draco, which is a very faint constellation, but once you actually get the hang of it, as it winds its way between Ursa Major and Ursa Minor and over to the top of Cepheus, it's a very rich constellation, and it is quite easily seen, particularly the little triangular head of the constellation, the head of the dragon. And Cassiopeia, obviously, one of the most recognizable constellations in the night sky, are all well placed. Cassiopeia, meant to be is it the daughter of Cepheus the king? I think that's right. The wife, I beg your pardon, wife of Cepheus. It just looks like a W to me, so it's easily recognizable. So let's take a quick tour of some of these constellations and some of the sites that are available to us, both as observers and as imagers, perhaps. So the first one we're going to look at is Orion, and this is a lovely wide shot by John Watson at the David Stirling Monument. I will confess my ignorance, I'm not sure where the David Stirling Monument is, but I have a feeling it might be in Northern Ireland. But you can just see over the shoulder of the statue there, high in the sky, is the three stars that form Orion's belt, and the line of stars with M42, the great nebula in Orion, hanging down as his sword. And you can also see the four stars that make up his shoulders and the bottom hem of his tunic. And just up to the right there is a sort of curving line of stars, which is variously shown in mythology as a shield, or I think a sheepskin, some kind of method of fighting anyway, because Orion is a mighty warrior. So within that area, it's a very, very rich constellation. It has a great deal to offer everybody. I've already mentioned M42, the great constellation. For imagers, particularly those with wide field instruments, there is Barnard's Loop, which is a very prominent area of gas and dust, which forms a semicircle to the left of Orion, and sort of almost encircling the whole constellation, which is not visible to the naked eye, obviously, but if you have a wide field image, it's quite easily seen, and it's part of the giant molecular cloud that is in the constellation of Orion. The Flame Nebula, NGC 2024. NGC, the letters stand for the New General Catalogue. It's one of the catalogues, one of the scientific catalogues of stars and objects in the night sky. M43 and M78, again, areas of nebulosity. And you've got the Running Man Nebula almost right next door to the M42, and the Flame Nebula, which is a lovely picture here by Andrew Farrow. The bright star off to the right here is Alnitak, which is a very bright star, and it gives you an idea. I mean, the star itself is just a point of light, but it's so bright that it's saturating the pixels on the camera. But it can be a tricky, the Flame Nebula itself, which is this area here, can be quite a tricky target to deal with, astronomically speaking, or astrophotographically speaking, because it is so close to the, in line of sight terms, it's so close to Alnitak itself. You've also got another one which will be a target that I'll be trying for this winter, I hope, which is the Witchhead Nebula, very close to the star at the bottom right of Orion, Rigel. And it looks like a witch's head in profile. And it's a lot of these nebulas don't quite look like how they're named. You have to use a lot of imagination. But the Witchhead Nebula does actually look like a witch's head in profile. So let's look at Perseus and what we have in Perseus. Now, Perseus always looks a bit to me like a giraffe. I don't know why. It's sort of a long neck and head here, and a small body and long legs. But again, that's just me. I don't think there's anything particularly giraffe-like about the stars themselves. But within Perseus, we have the famous double cluster, two open star clusters, which can be seen with binoculars and make a really fine target for astrophotography. The California Nebula, NGC 1499, is a beautiful target with lots of hydrogen alpha light being emitted by the nebula. And it's very roughly, if you use your imagination, it's meant to be shaped a bit like the state of California, hence the name, the California Nebula. And this is a lovely image by Pat Devine. Looks a bit like a squid to me, that one, I have to say. We've also got smaller targets like the Little Dumbbell Nebula and the Open Star Cluster M34. Open star clusters are wonderful targets because they've been described as jewels spread out on black velvet, and they can be very like that because a lot of the stars, depending on the type of star it is, can be multicolored, and some bright, some not so bright. So they can be fascinating targets to take photographs of, or if you have the right equipment for looking just to observe. Okay, and this is a picture by our colleague Hugh Somerville of M34. It gives you an idea of the spread of stars in M34 that I was talking about. A constellation that often gets overlooked between Orion and Gemini, Moneceros. I hope I'm pronouncing that correctly. And it is actually in the middle of what's called the winter triangle. You've heard of the summer triangle. We now have the winter triangle made up of Betelgeuse, Procyon, and Sirius. And back to Betelgeuse is the classic winter triangle. And in the middle of all that, we have Moneceros here. It's a very faint constellation, so it's not easily picked out by the naked eye, especially if you've got a bit of light pollution around. We have the open cluster M50, which is again a nice sight through binoculars or a small telescope. And we have other areas of nebulosity and star clusters. The Christmas tree cluster and Cone Nebula are quite an excellent object for photographers. And the famous Rosette Nebula within this constellation as well. And here is a lovely image of the Rosette Nebula, again by Pat Devine. These are in the Hubble palette of colors. Very often, if you take a photograph of the Rosette, as the name suggests, it's a nice red color because of the hydrogen alpha emission. and Auriga, which is in the situated more or less in the Milky Way. So any time you sweep across these constellations, you'll pick up a lot of stars, very rich star fields. Capella is the sixth brightest star in the sky, and the main star in Auriga. It is, I use it quite often for obtaining focus with my telescope, because it allows me to get very nice diffraction spikes with using a Batonov mask, which is a device that astronomers, particularly astrophotographers, will use to obtain a good sharp focus. Again, we've got lots of open star clusters, M36, M37, and M38. And another nebula, the Flaming Star Nebula, not to be confused with the Flame Nebula in this constellation, IC 405. And here is an image of this by our friend Ian Smith of the Flaming Star Nebula. Wonderful detail in that, and you can see that the background of stars is indeed very, very rich. Gemini, the twins, a sort of constellation that once you find it with your eyes, you can generally, in a dark site, you can pick out most of the stars of the constellation. But the two stars that mark it out particularly are these two, Castor and Pollux. And we have, again, a whole host of nebula and clusters, M35, NGC 2420, NGC 2158, the Eskimo Nebula and the Jellyfish Nebula, and the Medusa Nebula, also known as Able 21. And here's an image by Mark Phillips of Able 21. And Taurus, looking at Taurus, the bull just up a bit and to the right of Orion. This area here, the Hyades, forms, to the naked eye at least, forms a rough V shape, which is the head of the bull. And if you follow a line out to this star here and this star here, these ancient people imagined that, in fact, in a lot of cultures around the world, imagined that to be a bull with the long horns charging at Orion, who's down here in the left corner. And in fact, there's also a very famous open cluster, M45, the Pleiades, the Seven Sisters, just up to the right of the Hyades and the bull's head. And in fact, if you go online, you'll find that there's cave paintings, I think it's in Lascaux in France, which are many thousands of years old, 40,000-50,000 years old, with representations of the constellation of Taurus and the Pleiades, quite recognizable, painted on cave ceilings. Within Taurus, you've got Aldebaran, the red eye of the bull, which is it's a rather bad chart, but I think it's about here. I think that might be Aldebaran there, which is a red giant, and a very famous variable star, Tau Tauri. I've mentioned already the Pleiades and the Hyades, and the Crab Nebula, which is up in this area of at the tip of one of the bull's horns, which is the remains of an exploded supernova, which is mentioned in Chinese records from I think about the 9th or 8th century AD. And here is another image of that same supernova remnant, again by Hugh Somerville. This is it's a nice picture because it's a very tricky subject to catch. requires quite a lot of magnification because it's quite a small object, but very, very recognizable. And it's one of these constellations that I have no idea why it's called the Crab Nebula, because it doesn't look like a crab in any way, shape, or form that I can see. So that's what to be thinking about in terms of the constellations and the what's in the deep sky, as astronomers call it. Let's turn our attention now to the solar system, and in fact to the sun itself. So the winter solstice will take place on December the 21st at 15:59 hours GMT, or UHT as it now is. And these are, oops, sorry, I'll go back one. These are the ephemeris for the sun. And if you remember, I was mentioning that we have quite a number of hours of darkness. It's gradually, as you go through the month, the sun is gradually rising later and setting earlier as the month goes on. And we have evening twilight and morning twilight getting earlier and earlier, and morning twilight starting later as the month goes on. And was Sean already mentioned, the big news this month, we have that most fabulous of events. This is a marvelous image of the sun. You can almost feel the heat from it, from Peter Black. We have the great event of a total solar eclipse, but not for all of us. It will be happening on the 4th of December, tomorrow. However, it will be happening in the place that Will mentioned a few times, which is one of the driest and most barren places on Earth, almost untouched by humankind. It's taking place in Antarctica. And this is the path of totality, which will sweep round to the south of the Antarctic Peninsula. The end of the peninsula carries on up over the Strait of Magellan and into the tip of South America. There will be partial solar eclipses visible from Southern Africa, from Tasmania, and I think also from New Zealand. But the total solar eclipse will only be within this area here. I think from looking at some of the maps that actually the British Antarctic Survey Base, which I believe is around about this area, it's quite hard to interpret this map, but I think it's in this area roughly. So it may be that we'll get some nice images of that total solar eclipse from that scientific community. The other major solar system object, which most people are aware of, the moon in December. Again, a lovely picture of the Apennines on the moon, and quite a number of very nice crater images from Hugh. So new moon is on the 4th, that's tomorrow. The first quarter of the moon as it's waxing, in other words, moving from right to left and being lit by the sun. The first quarter is on the 11th. And on the 19th of December, middle of the month, we have the full moon. And then finally, on the 27th, we're moving into the last quarter when the moon is said to be waning. In other words, again, the lit part of the moon is on the left-hand side as you look at the moon. As we're going to see later on, the moon gets itself involved in quite a number of encounters as we go through the month. A beautiful image here from Radim, our colleague in Central Europe, of the crater Plato and what's known as the Alpine Valley on the northern half of the moon, the northern part of the moon. But what I want to tell you about is there will be a lunar occultation to observe You'd think these things happen fairly often, but ones that are visible from the Earth are reasonably unusual. This one is in Leo, where the star Eta Leonis, which forms the sort of front shoulder, if you like, of Leo, the constellation of Leo. There's the body of the lion's head, and the lion's haunches at the back. So in the front shoulder, Eta Leonis, the star here, will be obscured by the moon on the early morning of Christmas Eve. So if you've had enough of preparing for Christmas, then get yourself up out of your bed, because this star will be occulted by the bright side of the moon, the lit side of the moon, at 4:26 a.m. To reappear at 5:09 a.m. from behind the dark limb near the top of the moon, near the northern cusp. It will pop back into view. These times are good for our location here in Edinburgh. So if anybody's watching this from further afield or in a different place, then please go online or get some other kind of reference to get times for your local location. Moving on to the planets. The planets are not so easy at the moment. Mercury is going to put in an appearance. It's a tricky target for both photographically and visually. Because it's very small and not that bright, but also because it's very close to the sun, being the nearest planet to the sun that we have. So you've always got to be very careful when observing Mercury that you know exactly when the sun's not going to be there, because you don't want to be observing it and inadvertently catch a glimpse of the sun through an instrument or even with the naked eye, because it will not do your eyesight any good whatsoever. So Mercury may be seen near Venus soon after sunset towards the end of the month. Venus itself is still with us. It's been with us for quite a long time. It's very low at the moment in the west, low in the southwest, but it reaches its greatest brightness tomorrow on December the 4th, when it will shine at a magnitude of -4.9, which will easily pierce the twilight. So you'll see a very, very bright jewel hanging in the sky to the southwest, quite low. And a waxing crescent moon. I said that the moon is going to photobomb or gate crash a lot of events this month. A waxing crescent moon, complete with Earthshine, will join Venus on December the 6th, about 3 degrees away from that. So again, that will be a lovely photographic opportunity. Now Mars, again, a difficult target because it's low, and also it will be appearing in the pre-dawn twilight. So if you want to take a look at Mars this month, you will either have to not go to bed or to get yourself up out of bed. It's in the constellation of Libra throughout the month. And then I'll come back to Mars because there's a couple of other things I'll point out about Mars. Jupiter and Saturn, which have been with us for quite a long time, albeit quite low in the sky to the south and to the west, are now both losing altitude, still visible through December, but they'll be more difficult to observe and more difficult to photograph. So this is the photographic opportunity that I was thinking about, because Mars itself will be in the constellation of Libra. It will form a nice triangle with the moon and with Antares, and it will give you quite a good opportunity to also take a look at the lovely star Zubin al-Ganubi, which is a favorite just because of its name with the Astronomical Society of Edinburgh. So this view is on December the 31st, the very last hurrah of the year, an hour before sunrise, looking to the southeast. Okay, and we're still on the planets. A beautiful image of the night sky on the west coast of Scotland by Pat Devine. And we're going to look at two other planets which are visible to us through this month and are a bit better placed. Uranus at a magnitude of plus 5.7 in Aries, and Neptune a magnitude of plus 7.8. So Uranus should actually be quite a nice naked eye. You should be able to see it with naked eye, and certainly with binoculars or a small telescope. And these will be, this is a lovely picture of Neptune by Mike McGovern, a pale blue dot hanging in space, one of the ice giants that NASA will be investigating through this decade. And later on through December, there will be quite a parade of planets because you will have Venus, Saturn and Jupiter, which will be over successive nights of the 6th, 7th, 8th and 9th. The crescent moon will make its way through a line of planets. And indeed, with Mercury towards the end of the month, Mercury will appear to be approaching Venus between the 25th and 31st in the twilight, before Venus starts to really disappear for the rest of the winter. So that means that, in fact, in the last week of the month, with Mercury putting in an appearance, all the major planets of the solar system will be visible. And because with the last week of the month being at its darkest, then assuming that we get clear nights, there should be a lot of opportunity to tick off planets. And a bonus, the asteroid Ceres, which is the largest asteroid of the visible asteroids, it will be in Taurus. And this will be the path that it will take. There's the Hyades that we were talking about earlier, and Aldebaran, the orange star or the red star, Aldebaran. And so to the right of the Hyades, from December the 1st through to the end of the month, you will see a bright dot tracking its way through the stars. And it would be an interesting exercise to take a look every few days, perhaps a photograph, a wide field photograph, and just track the movement of Ceres through the star field. And more dwarf planets will be available to us. Now, I've no idea how to pronounce these, so I'm just going to make a go at it. Makemake and Haumea are two large asteroids visible in the east towards the end of the night. They will be in, Makemake will be in Coma Berenice, just to the right of Bootes and down a bit from the Plough. And Haumea, again, is just to the other side of Arcturus, which is the bright star at the bottom of Bootes, in that position here, over to the east. So if you have a clear view to the east, you should be able to pick these up. These views are for the early morning of the 6th of December. And finally, we have two meteor showers. The Geminids, which, as the name suggests, is a meteor shower, which is perhaps a source of some of the meteorites that Will hunts for, is widely regarded as the best and most reliable show of the year in terms of meteor showers. However, it might be spoiled to some extent by a waxing gibbous moon coming into the picture until about 01:30 in the morning, when it will eventually set. But you should still be able to see a lot of meteors. The radiant, or the point at which the meteors appear to originate, will be near the bright star Castor in Gemini, which were the two stars we spoke about earlier, Castor and Pollux, the two brightest stars in the constellation. So there's the constellation, and we can see there's Castor and Pollux, and there is the radiant from where the meteorites will appear to come, although they can come from all different quarters of the sky. And this particular meteor shower is the remains of comet 3200 Phaethon, because it goes through the debris field of that comet. The Earth is going through that debris field, and it has an hourly rate of typically 60 to 70 meteors an hour. So you should see some, if you're comfortably set up and keeping watch, you should certainly be able to see some meteors shooting through the night sky. There's also on the 17th to the 26th, there's a far less bright meteor shower, the Ursids in Ursa Major, which has a much lower incidence of meteors. But again, perhaps worth a look if you have a dark sky. And we also have, as well as meteors, we have comets. We have, in fact, 3 comets visible in the UK, likely to be above 10th magnitude. So they should be quite readily targeted with small to medium-sized instruments, or in some cases binoculars. And one of them might become a naked eye object. It might just get to that crucial point of about magnitude 5 when it can be spotted with the naked eye. But we'll come to that in a moment. In fact, we'll come to it now. That's Comet Leonard, which between the 1st and the 13th of December will be tracking southwest through Bootes, Serpens, and Ophiuchus. And it will have a close encounter with Messier 3 on December the 3rd. So here we have it in Canis Venatici on the 1st of December, and running down and to the left past M3, past the star Arcturus. Again, a little bit low in the sky, but it should be possible to follow it. And it may or may not develop a tail. It may or may not get brighter. It may or may not be a naked eye object. We'll have to wait and see. But as you can see, there's quite a number of Messier objects in its path as well. So again, for imagers, it might be quite a feast. And we have 2 more comets, L3 Atlas, which will be in the extreme southwest corner of the constellation of the Lynx in the first half of December, and then we'll move into Gemini on the 18th, possibly a magnitude of +9, which means it won't be a naked eye object, but it certainly should be. You should be able to acquire it with a small telescope or an instrument of that sort. And Comet 67P, Churyumov-Gerasimenko, will be a fine target in northern Cancer throughout December, possibly reaching a magnitude of 10.3. So thanks very much, and clear skies to you all.
Right, thanks very much for that, Nigel. That was brilliant. That brings us to the conclusion of our meeting tonight. Thank you all for bearing with us while we had some technical difficulties. It struck me as the presentations were going on there, just how rewarding it is to be able to use a telescope. Some of the images we had here tonight by our our members are the kind of images that, quite frankly, 20 years ago, a professional astronomer would have been more than proud to be able to image. So for those of you who'd like to know more about using a telescope, as we said earlier, please email in if you're interested in attending our telescope workshop, and we will accommodate you as best we can. A brief reminder again, our imaging group will be meeting virtually next Wednesday, the 8th of December. And of course, we'll have an online presentation from Martin Lund on the 17th of December. We're going to be going off YouTube now,